Welcome back to a new video. In this video we are going to be talking about the z-score. We are going to be talking about the formula, idea behind it, and how we can implement that in Python. Let's start coding. I'm in VS Code right now. You can use any code editor that you want. It's completely up to you. So what I'm going to do is I'm going to close this welcome page. I'm going to create a new file with name z-score.ipynb. So we are going to work on a Jupyter notebook, and let's select our kernel Python 3.11.4, and let's say for the topic z-score. So let's talk about it. Z-score is a statistical measure used to identify outliers in a data set. It represents how many standard deviation a data point is from the mean of the data set. Data points with z-scores beyond a certain threshold, we generally use like 2 or 3 standard deviations, are considered outliers. And in this short tutorial, we are going to talk about its mathematical formula, how we can code it in the Python, and how we can identify and filter out the outliers. So let's start with the mathematics behind that. So the z-score formula is z equals to data point minus mean divided by standard deviation, like this. And let's say like math, and we can set it like this. So in here, z tells us how many standard deviations a data point x is from the mean here, and x is the data point that we are taking a look at, and mean is the average of all data points, and standard deviation measures the spread of data points around the mean. So let's code it. I will say import numpy as mp in a Python cell, not a markdown one. And then I'm going to make it run, and let's create a sample data, like it's going to be a basic array. Let's say 70, 75, 80, 85, 90. And now I'm going to make it run. And firstly, let's calculate the mean. So for the mean side, we will say mean is going to be numpy.mean, and we'll get the data. Now let's see our mean, it's 80, and let's calculate the standard deviation. So it's going to be standard deviation is going to be numpy.std, which stands for standard deviation. We will pass the data inside, and I will set this as 0 for getting the population standard deviation. For sample standard deviation, you can set this as 1. So I will go with 0, and then we are going to be computing the z-scores for each data point. So this is going to give us how far each data point is from the mean. And we have the mean and the standard deviation right now. So we can say z-scores, and they are going to be data minus mean. By the way, let's bring our formula in here. We are going to apply this formula, vc, I will say code, and actually let's create this in a markdown format. So data point minus mean divided by standard deviation. So we will say standard deviation, and I'm going to call the z-scores. Here is our array. So also let me call our data, and we can see that our mean 80. So let's also display that. Our mean is 80. So 80 is no distance from a mean, so it's 0, and our second element 75 is minus 0.7 standard deviations away from a mean, and our first element 70 is minus 1.41 standard deviations away from the mean. And we can see that we have the 0.7 and the 85 part, and we can see that we have the 1.4 in the 90 part, and we can create a for loop for displaying it better. So we can say for index in data, and we can call like print, we can say f string, and we can say index is z-scores index standard deviations away from the mean. And let's print out for seeing what's going to be the output. Okay, we are going from data, so we can create something like indexer, and it's going to be 0. So we can say indexer, and it's going to start with the first index. Now we can say like indexer plus equals 1. So this is going to work out smoothly. Yes, 70 is minus 1.4 standard deviations away from a mean. 75 is 0.7 minus 0.7 standard deviations away from mean. 80 is no away. 85, 90. Great. So we can have our z-scores like this, and let's identify outliers. Data points with z-scores beyond a certain threshold, commonly it's 2 or 3, are considered outliers in both ways, like negative 2 or 3, positive 2 or 3, but we don't have any that in our data, like the maximum is 1.4 in each side. So let's create new data points in the data, like let's say 110. So, and we can say it's going to be enough, so I'm going to make a run of that again. I will make them all, and I will call numpy.mean this time. So our z-scores in here. So by the way, we are still not in the 2 sides, so let's increase this to 130, and I'm going to say run all. Now we can see that we have 1 which is more than 2 standard deviations away from mean. So let's identify the outliers. Our new data is going to be this, and now I will say let's define a threshold, like let's say 2 standard deviations is going to be our threshold, and outliers data we are going to filter it like numpy absolute z-scores greater than threshold, and we can call outliers like this, and our outliers are in here. It's 130 only. And if you create new data points, like let's say we have 130 in here, and also let's create something like 20. So let's see our outliers right now. Here is outlier list, and we won't have any outliers since the mean is going to be changed. And if we change this threshold, like if we are checking the values which will return our new array, like now we need to get 130 with 20 since they are more away from the 1.5 standard deviations. So we have them in here. Great, amazing. So let's summarize what we do. Firstly, we start by talking about the z-score, why we use it. Then I showed you the formula behind calculating the z-score, and we imported numpy for this tutorial, and I created an array. We edited it a little bit, but it doesn't matter. And we find the mean in here, and our mean is 78.5 in this new data, and we have the standard deviation here. Let me call that 2, like this, and in here we calculate the z-scores. Here are our z-scores. Then we set for loop indexer 0. For each index we printed the standard deviation distance from the mean, and we identified the outliers with defining the threshold as 1.5. By the way, let's write that too. Common values are 2 and 3, and we filtered out the outliers and we printed them, and this is how we can identify the outliers in Python. Thanks for watching this tutorial. I have a playlist named Data Analysis Tutorials where I have more videos just like this one. You can check that playlist from the cards of this video. Also, I'm sharing a new data science video every week on my channel. You can subscribe to my channel for more videos like this. Have a great day.